In the last section of our module DNS risk analysis, we will take a closer look into the different trust sectors that a DNS server can be located in. When it comes to trust sectors and trusts in an infrastructure, we can start with a very simple framework that was released by the National Institute of Standards and Technology, and it is divided into the three topics of identify, protect, and detect. Identify means you should know what are your physical systems, what are your systems, which means the operating system and stuff like that, what software platforms and applications are running on these systems, what is the organizational communication between these systems, how is data flowing, and if there is any external information system, how is your infrastructure interacting with this one. When it comes to the protection, the best way is to create segments in your network. There is this new concept of, how is it called, zero trust networks, which is a pretty interesting idea, I would say. But if you have a look at the current situation for most of the enterprises, this is nothing that will be in place in the next 10 or 20 years all over the world. It takes some time to make this transformation. So segmentation at the moment is a pretty good idea. Then you should have a proper capacity to ensure that your environment is available. We already discussed this at the beginning of this module. And you should protect the communication and the control channels to and from your systems. And at the end, you should detect if something is happening. So you should know what is the expected data flow to identify if something gets wrong. And this is quite interesting to see in a lot of customer environments that I have seen in the last couple of years. It's not totally clear to the administrator how a single DNS query gets resolved, because there are multiple caching systems, there are primaries and secondaries, and some secondaries don't have all the zones like another secondary. So in some cases, they don't really have a clue how the answer is provided and what the way or the path was that this came to the client. And this is quite important. An administrator has to have a pretty good understanding what are the DNS servers, how they are configured, how do they communicate with each other, and if a client asks for a specific query, an administrator should be able to make a proper expectation how the data flows and how the answer will reach the client. There are some general principles when it comes to the deployment of a DNS infrastructure. For every zone that you have, you should have a primary and at least two secondaries. And the secondaries, for sure, they should be located in different networks or areas. The primary should have redundant hardware if it is running on hardware. The authoritative servers need to be in different subnets or locations, and in specific cases, for example, when it comes to external DNS, this is actually a requirement from your parent zone. So if you would like to have a delegation, you need to have at least two systems to delegate to. That's quite common policy. And these two systems have to be in different network areas. So it's not allowed to have the first server on the IP address something 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 .7 and the other one at something something .8. This is not allowed, so there should be some kind of distance between the systems, and it's quite useful if you have any kind of partner organization. I have seen this with universities all the time. They are just placing a secondary of their own data at the infrastructure of the other university and the other way around. This is quite easy to implement, and for enterprises this would be possible as well. The authoritative servers should be quite close to the clients, or at least to the resolvers that are in front of the clients for a much better performance. This really depends on the architecture, and it's not always possible to keep this in mind, but we will discuss this a little bit later anyway. Load balancing is a proper easy way to implement DNS redundancy, because if there is a load balancing infrastructure in place already, placing some DNS servers behind this is a simple way, and then you are more flexible when it comes to updates and patches and stuff like that. You should use different servers and different vendors to handle the different types of queries, or to represent the different roles that a DNS server can play. So external and internal queries should be handled differently. Recursive and authoritative queries should be handled differently as well. At the end, it makes sense to have dedicated recursive servers that are only used to support the clients. So in that case, the clients are not using the authoritative systems directly. They have a recursive server in front of it. We are going to discuss this in this module as well. The trust sectors can be divided into 4 primary sections, depending on where the query is coming from and what the query is actually asking for. So if it's an internal one, if it's an external one, and if the query is about an internal resource or an external resource. And now we are going to deep dive into these sections in the next couple of slides. The first trust sector we are going to cover is the external trust sector. So this is the infrastructure that everybody else on this planet is able to access, which is needed, for example, to access your websites, to send you an email, or to download an app that you are providing for your customers and stuff like that. So you are providing some kind of services for the rest of the world, and this is the DNS infrastructure that you need for this. What we can see in this diagram, we are using a hidden primary. This is highly recommended in external DNS. We have a bunch of secondaries in a dedicated DMZ. There are firewall in between, and you can assume that the internet can only access these 3 systems over UDP and TCP port 53, and you can also assume that only the internal IP of the primary is accessible from the secondaries for zone transfers, for example. With regards to external DNS trust sector, we have some basic configuration approaches that we can just address. For sure, you would like to disable recursive queries at all. Otherwise, there's the risk that you are just providing another open resolver that can be used for some of these attacks that we have seen, or maybe it's just used heavily that your actual DNS answers are slowing down. The zone transfers between the primary and the secondary should be signed. This is something that you can easily do with keys that are pre-installed or pre-configured actually on the 2 systems or at least 3 systems to sign the zone transfers, which makes the management quite easy because you don't have to manage ACLs with IP addresses all the time, so you can just change your secondaries and the primary will still accept the zone transfers. The primary should only use the internal IP addresses for notifications and zone transfers, and when it comes to a hidden primary, the secondaries in the DM set should only use the internal IP addresses to query the primary, for example, to check the serial of the SOA record if there are any changes. Sure, if there is a management system in place, and this is quite common with most enterprises, it shouldn't be a system where everybody has access to. There should be an option to just allow a portion of the environment to be managed. Typically, a DNS server is able to give you an answer what vendor and what version is running. This is a specific DNS query that you can send. In most cases, it's disabled per default, but you can just double check if this is the case, just to be aware if somebody outside is able to identify the vendor and version of your system. You have to secure the server itself, and you have to defend against attacks, and we are going to discuss this a little bit later. And for sure, it makes sense to protect the authoritative data itself by signing the zone information. This is covered by DNSSEC. We will discuss this a little bit later. The DNS can be hosted somewhere. So if you don't want to provide your own DNS infrastructure for something like that, or maybe if you don't have the resources to provide a proper DNS infrastructure and you're relying to another company to do that for you, here are just some ideas what you should keep in mind. The user access to this external management system should be unique, so it shouldn't be a default account that is shared with multiple users. Everybody should have a user account, and if an employee is leaving the enterprise, this account should be cancelled. The communication with the management system should be encrypted. So in most cases, it's a web interface that the provider is offering, and it should have HTTPS connection. And for everything that is done in the system, there should be an audit log to just identify what was happening. Because we are talking about external DNS, please, if you are using an external provider for that, keep in mind that DNSSEC is something that is quite important to implement. And if you do an evaluation of different providers, this should be one topic that you should really care about. And there are a couple of other features that could be useful. Things like ACLs or GeoDNS or rate limiting. This really depends on your provider or on your actual needs. The provider should offer a proper service level agreement that fits your needs. If you are providing an online shop, I'm pretty sure you expect your customers to buy in this online shop 24/7, and the DNS infrastructure should cover that. The system should have some preparation against denial of service attacks, and we are going to discuss this later. And it would be cool if there is any kind like parent domain security controls, which means that some providers are checking the delegations from the parent zone to your domain frequently. So if somebody is hijacking the DNS of the parent, you can recognize this easily if somebody is monitoring this. Something that you can keep in mind with regards to diversity, it really makes sense to have multiple DNS servers in different geographic locations. That means that the systems should be placed not in the exact same AS area, for example. The implementation should run on various implementations, and if you would like to use external provider, it makes sense to use more than one provider, because maybe somebody is not attacking you but is attacking your provider, so you are just collateral damage if your provider goes down. And so it makes sense to have at least two providers, or you can even combine this, that you have your own systems in place, and you are just using a couple of external providers to keep secondaries in different locations, so that you have a much better setup for your external DNS. Another section in your DNS infrastructure is the extranet. This is the DNS that your partners are using. Quite huge companies belong to some groups, for example, some business groups, and so they are sharing parts of their business. They are independent companies, but they are sharing some resources, and these resources need to be able to be accessed by the clients of your partner, and it really makes sense to have a proper DNS infrastructure that is isolated from your standard DNS infrastructure. So the extranet actually means that some of your partners is using your internal DNS to access some databases or whatever. The access to this part of your DNS infrastructure should be completely limited to the partners. In most cases, the communication from the partner is terminating in some kind of a DMZ or dedicated network that is somewhere in your data center, but it's not the standard data center networks that your internal clients are using. The resource records in these specific DNS zones should be isolated from the rest of your infrastructure. It really makes sense to have dedicated zones or dedicated zone files in this infrastructure if they are using the exact same DNS zones. So if you have something like internal.example.com where you are providing some data, and unfortunately your partners have to access resources within that namespace, and you can't provide a dedicated subzone just for partners, for example, then it really makes sense to think about something that is called a split DNS, so that you create a subsection of your internal DNS and you provide this as a dedicated DNS server just for your partners. In some cases, it makes sense to have a different DNS resolution for different partners. I haven't seen such a requirement in the field. So in most cases, if companies are providing any kind of database access or storage exchange or something like that for partners, it's the same for all the partners. I haven't seen anything like a dedicated email or dedicated DNS or dedicated storage for different partners. But if that's a requirement, and maybe in some businesses like maybe banking or military development or something like that, it could be the case. And for sure, these DNS servers should only accept queries from the DNS servers of your partner. A quite important sector that offers a lot of capabilities in your DNS infrastructure is the recursive DNS sector. So in most cases, these are the systems that are in front of your clients. So that your clients should not query your internal authoritative DNS servers directly. It makes sense to have caching in front of it. And as we see on this diagram, the caching can have multiple levels, so that you have internal caching systems and then dedicated caching systems for internet resolution, for example. And for the recursive DNS, we have also some recommendation when it comes to basic server configuration. The caching servers could be a multi-tier infrastructure. As I mentioned just a minute ago, it could make sense that you have a caching infrastructure for your clients, another caching infrastructure for your data center, and a third caching infrastructure for your internet resolution, and that only the DNS servers in these dedicated systems are allowed to communicate with each other, so your clients are not talking to a DNS server that is connected with the internet directly. So there are different levels in front of it. Because this is a recursive infrastructure, there should not be any zones or resource records configured. So these boxes only do recursive DNS and forwarding and all this stuff. They don't host any DNS data. In addition, you can have IP address filtering on firewalls and routers in front of these boxes, especially for the recursive servers that are public facing. It really makes sense to prevent external clients to use these recursive servers, otherwise you would have another public resolver. The next topic, disallow dynamic updates and zone transfers, is something that sounds obvious because we don't have any zones and records, so typically we don't have dynamic updates or zone transfers, but it really makes sense to configure this specifically to disable dynamic updates and to disable zone transfers completely, because if this is not available, it can't be used by somebody else. And maybe because of some misconfiguration, some of your DNS zones, for whatever reason, happen to be stored on the recursive servers, maybe some misconfiguration in your management, then you want to ensure that no zone transfer or dynamic updates are possible. Like with all the other trust sectors, the access from the management should be limited. So multiple user accounts, multi-factor authentication, audit logging, yada, 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 all these things. And we will discuss a couple of things a little bit later, how to secure the server, how to rate the query limit, and we will also talk about DNSSEC validation and DNS firewalls a little bit later in that course. Your entire internal infrastructure highly depends on the internal DNS trust sector, so this is where your internal DNS records are hosted and managed. The recommendations with regards to the internal trust sectors are as follows. Because we are talking about authoritative DNS servers, again, recursive queries should be disabled completely, and like with the hidden primary and the secondary in the external DNS, zone transfers should be signed with signatures, and the primary should only accept notifications and zone transfers from its known secondaries. And in some scenarios, you will have a hidden primary internally, and this one should only accept queries from the secondaries, even that it is an internal system. There was a reason why somebody placed an internal hidden primary, and for that reason, this box should only be accessible by its secondaries. The limitation of access to the management is something that is quite clear, and we will discuss things like securing the server and defending against attacks a little bit later. So here we have the entire bigger picture, but there is something in addition that we are going to discuss a little bit later, and this is delegation internally. But here we have everything in one diagram. We have at the top right corner, we have our external DNS with hidden primary and a couple of secondaries. On the left-hand side, we have multi-tier caching infrastructure that is used to do internet name resolution, and at the bottom we have the internal DNS for internal authoritative data that is only providing the internal resolution, and the black caching systems on top of this diagram are using this infrastructure to reply with internal queries to internal clients. There are some additional sectors that you could think about to implement depending on your requirements or depending on your infrastructure. There is something that is called internal delegation. So if you are a huge enterprise and if you have dedicated locations around the globe, and if they are somehow independent, so you have something for the Americas, you have something for Europe, you have something for Asia Pacific, then you could think about a proper delegation. That means that you create your primary systems in your headquarters, and then you are delegating subzones for the specific regions, and then they can manage their internal DNS in their dedicated zone infrastructure. But because of the delegation, they are still able to resolve the rest of the infrastructure, just in case that somebody from Americas needs to resolve a resource that belongs to Asia Pacific. The multi-tier authoritative configuration is something that is quite close to what I already explained with the internal delegation, so that you don't put all your eggs in one basket. So try to distribute your DNS infrastructure if that's possible. But I have seen things like DNS zones of an entire enterprise that includes everything, so just one huge big zone with 10,000 or 100,000 of records. This is something that is not useful if it comes to spreading authoritative DNS to different continents or different countries. In some cases, it makes sense to have a hybrid configuration of authoritative system and a caching system. So this can help to speed up the process of resolving DNS. So that means that if you have a couple of branch offices, that these offices are configured with caching systems locally. You could think about to also configure these systems as secondaries for the DNS of your headquarter or the DNS of your regional headquarter, just to speed up the process and to bring updates of your DNS into the field much faster. And this can be combined with the next topic, a stealth slave or a stealth secondary. This is the option that on such a caching box you can run the authoritative data of your company, but the servers are not published as existing DNS servers. So if somebody is using the proper DNS queries to identify what are the name servers for a specific zone, they will only see the name servers in the data center or in the headquarter or in the regional headquarter, but they won't see the DNS servers of the branch offices because they get a copy, but they are not published in the DNS zone itself. And this also helps to speed up the process of DNS resolving. And in some cases, it could make sense to install internal root servers. So that means that no external DNS resolution is possible at all. But if you need some external resolution because you would like to use some kind of service from somebody, then you have to add the top level domain and the second level domain manually to your internal root systems. I have seen this coming and going, so it was quite famous in the past, and then people tried to get rid of it because they were using more and more services that were provided in the cloud, and maintaining all these public domains was just horrible. Nowadays, because DNS is used for a lot of different kind of attacks, as we have seen already, some people or some enterprises are thinking about to recreate internal root servers. So this is something that, yeah, it really depends on the current trend or trends, if it makes sense to install this or not. But if you have a completely isolated environment anyway, so if you are for some reason completely isolated and you don't rely on any external DNS resolution, sure, feel free to just use root servers internally. There's also something that is pretty cool to configure. It's called Anycast DNS. In that situation, your DNS servers become kind of part of your routing infrastructure. So your DNS servers have to support some routing protocols like OSPF, BGP, or RIP maybe. So all the systems are configured with some physical addresses, but they are all listening to exactly the same virtual interface. So from a router point of view, there are just different routes to the same resource. So if something dies in between, the routing protocol will just take care that the now closest path is used to get access to the resource. This is quite common for internet DNS. So for example, huge infrastructures like the root servers, for example, or massive DNS infrastructures of DNS providers are using Anycast. But this can also be something that you would like to use internally. So let's just imagine that you have multiple locations around the country or around your continent, and you have multiple caching systems in place. This could help to just provide one single IP address to every client. Every client is configured exactly the same, using the same IP address, and the routing protocol is taking care that the client is always using the closest DNS server. And if this DNS server is not available anymore, the routing protocol will redirect the queries of the client to the now closest DNS server. Just a comment based on my experience, this really makes sense if the same department is taking care of the network infrastructure and the DNS infrastructure. If, for example, the routing infrastructure is something that you bought by a provider, and if you need any changes or any troubleshooting, you have to open a ticket, and then you have to wait for 2 weeks to get some stuff done. This is probably not the right way to implement Anycast DNS. But if this is all in your own control, it can be quite useful to think about such an architecture. Sometimes I get asked if it makes sense to install DNS on a remote site. The answer is yes and no. It really depends what the remote site means. If the remote site is dependent on services in the headquarter anyway, and if the communication to the headquarter is down and the location can't do anything, then why should you spend all the money to install local DNS? But if you are using some external services like cloud-based office solutions, or if you're CRM system is cloud-based, or if your mailing system is cloud-based, or whatever you would like to name it. It doesn't help if your locations also always use the DNS in the headquarter, because in some scenarios the location is quite far away from the headquarter, and it doesn't make sense to provide a cloud service to a location from another country or from another continent if this is the distance between the headquarter and the location itself. In addition to this, a local DNS can help to speed up the time that DNS resolution takes. So if you have any local or remote resources like file and print or telecommunication or whatever, it really helps to keep a little portion of your DNS in the branch offices. There are also some applications that are not implemented with a local cache. So in most cases, if you think about your browser on your notebook, for example, your notebook has this mini DNS server that I mentioned multiple times already. So your browser can use this cache for resolving IP addresses. So not for every click on a website you have to use any kind of DNS queries. But there are some applications or some special devices that can't do that. And in addition to this, even if you don't have DNS locally, most branch offices have domain controllers or any other authentication or authoritative authentication services on site. It really helps to speed up the logon process if your DNS is not sent around the globe for a local domain controller. You can reduce the load on your WAN links. DNS is a quite thin protocol, I would say. So it's not like using a lot of resources on WAN links. But if you have something like satellite connections, or if you have some little factories somewhere in the middle of nowhere because you are producing special stuff, then even DNS is something that can add a lot of traffic to your WAN links. If we are talking about branch offices in major cities and WAN links between these major cities, you wouldn't even recognize the DNS traffic on these systems, just in these special cases where you have very, very small WAN connections or just a satellite connection. In addition to this, if you keep all your DNS centralized, and if there is an outage, or if you are going to replace some end-of-life hardware, or if you are just going to install some security patches, you always have to keep in mind that all the other branches need to be informed about this. You need to have something like a downtime window, and a lot of paperwork or communication internally has to be done. And you can reduce the amount of effort that you have to put in something like this if you just keep some part of your DNS infrastructure locally. And in addition to this, it also helps to monitor your DNS traffic. As we just learned in the very first section of this module, everything relies on DNS. So every user that tries to access something and every application that tries to access any resource has to use DNS to establish this communication. And so you can use the DNS traffic to analyze everything that is not normal, everything that is behaving a little bit strange. And if you keep your DNS local, you will see which location in which country or which client is doing this. If you keep your DNS completely local, sorry, not local, if you keep it in your headquarter, all you see is the IP address of the router from your branch office. So you can maybe identify that something strange happened on a specific location, but if this location has 1000 IP enabled devices, this information won't help much. To sum it up, just keep it simple. I really like these two comments made by Paul Wixie, who is one of the most known people in the DNS industry, actually. It really makes sense to keep two DNS servers for every campus. So even if you are just one huge big company, it's not quite common that you were able to place everybody in one huge building somewhere on a green field. There will be some distribution between buildings and cities or even countries or continents, and everything that looks like something that you can call a campus, just place two DNS servers over there. And another comment that I really liked was keeping the architecture small enough to fit on one slide is the key to evolution. This also counts for the simple DNS infrastructure of an enterprise. We have seen in this section especially that you can combine a lot of different things, different roles, different approaches and stuff like that, but just keep it as simple as possible. When it comes to separating services, for example, keep in mind that this only makes sense for bigger locations. To separate the different phases of DNS for a little branch office of 60 people really doesn't make sense. So just keep it as simple as possible, but also as reliable and secure as possible.